Okay, now let me just start off by saying that I am a bit reluctant to make this video. This, quite frankly, this is a subject that would be much better for someone like Joe Pazinski to do because he's, so talented with the mathematics on machining, but he doesn't have a Hindi lathe, so uh, until he gets a Hindi lathe or something as convoluted as that, it's going to have to be one of us Hindi owners. So, well, first off, let me bring you around and kind of show you what the debacle is. Feed speeds are 4 times threads per inch. So, given that, you take this chart on the quick change gearbox and you calculate out how many thousandths of an inch per revolution of the chuck the carriage travels. Now, is that clear as mud? So, a fellow by the name of Claude W. asked the question earlier today. Actually, he's the second person to ask me the question, and neither of which I could answer correctly. How the feeds were calculated on this. And he apparently is a professional machinist, as I understand it. So he did a little bit of calculating on his own, and he came up with a formula that seems to work. The whole 4 times thing doesn't work for me. Apparently it didn't work for him either. But at any rate, one of the things he came up with, he gave me this first number. With the quick change gearbox set for 80 threads per inch, for threading, the carriage will travel 0.0125 thousandths of an inch per revolution, per spindle revolution. So, what he came up with is he took this 0.0125 and divided this by 4. As a result, he came up with a feed rate for cutting, not threading. He came up with a feed rate of just a smidge over 3 thousandths per inch. So I tested that theory out on my lathe, and it works. So he gave me the first row of numbers, and then I extrapolated. I don't know if that's the correct term or not, but anyways, I multiplied it times 2 times 2 times 2 to get the same, or to get the feed rates at the 40 TPI setting, the feed rate at the 20 TPI setting, and the feed rate at the 10 TPI setting. So after I started to kind of feel comfortable with the formula that he came up with, I went out on my own and I wound up setting the lathe up to cut 3 threads per inch, engaged my half nuts, and came up with approximately 333 thousandths of travel. Now, granted, that's assuming I didn't bump the DTI in the process of manually rotating the chuck around. Anyways, taking this 333 and dividing it by 4, I came up with 0.083. Now, when I actually put that into application, disengaged the half nuts and re-engaged the feed for the carriage, I wound up coming up with about 93 thousandths per spindle revolution. Now, granted, again, I could have bumped settings, I could have miscalculated, I could have done any number of things wrong, but this seems to work. Or at least seems to work well enough that it can get us hendey owners by. I mean, not that any of this matters. I'm just, on the rare occasions that I've been feeding or using the auto feed on this thing, I just am going by feel anyways, but it absolutely drives me bonkers not being able to understand what the quick change gearbox is trying to tell me. So I would love to hear back from the people, you know, that are watching my channel that are a hell of a lot smarter than me as to, I guess, how would you get the math to work out correctly for well, let me bring you out around here once more. How would you guys get the math to work out correctly for 80 threads per inch times 4 to be 3/1000ths of an inch? This is the part that I cannot wrap my head around at this point in time. Like I said, Claude's math works. I can make Claude's math work for me. But as far as getting it to work the way Hendey says it, it doesn't seem logical. In fact, when I first saw Handyman's post on Practical Machinist, I was actually taking this number times 4, and obviously that doesn't do a darn thing for you. But Handyman has a great write-up on these Hendey lathes as far as calculating the feed in thousandths of an inch per revolution, but I was not able to make heads or tails out of it. So it would be awesome if any of you guys that are good at this have some information to pass along that might make this a little bit clearer for others in the future. Because this video I think is just going to be me kind of putting it out there because I clearly can't easily explain this. And I'd like to make a good, proper video with regards to how to determine the feed speed on these Hendey lathes. So basically this is just a primer, I guess you could say. Anyways, so since I've got you guys here, I'm going to reset the gearbox for 80 threads per inch, and I'll bring you guys around. Okay. 80 threads per inch. This right there. And this guy in one. Okay. Now then, I need to lock this. Oh, it already is locked. Okay. And what I've done here is, maybe it won't show up, but I've got a little pencil mark on the chuck and the collar of the lathe. I'm just going to, once I get all my lost motion squared away, I'm going to rotate the chuck around 1 revolution by hand. Now, I know that this is glaring, so unfortunately you'll just kind of have to take my word for it that this is traveling 3 or so thousandths of an inch per chuck revolution. So, okay. Do I have everything engaged properly? Yeah, okay. All right, let me get this. Okay, there's my starting point. Now I'm going to zero this guy, or try to zero this back out. All right. Let me bring you in close so I can get away from the glare. Maybe I can get away from the glare. There. So just about got it set at 0. It's kind of hard to compensate for the parallax error with looking through the camera, looking around the camera, etc., etc. At any rate, I think I've got the lost motion accounted for. So I'm going to rotate the spindle 1 full revolution. Very carefully. All right. Well, I must have done something not quite right, but at any rate, I'll show you what I got. I got better results the first time I did this when you guys weren't watching. So this time around, I got to about just under 3 thousandths of an inch, or about 2.5 thousandths. But at any rate, it seems to be a working calculation, a working equation that Claude has come up with. So anyways, I think I've rambled on more than long enough on this particular subject. If somebody has some insight to add to this, I am all ears. And if by some stretch of the imagination Joe Pazinski chimes in on this, that would be, well, awesome. So anyways, I'll catch up with you guys later.